There are going to be times when you're asked to solve an equation and it looks like there are variables all over the place and numbers all over the place. This is a case where you're going to have to combine like terms first and then solve for the variable. If you think about combining like terms like putting silverware away, now the way we do things at this house is there's a spot for everything. It's almost like combining like terms because the same things go together. And you have to be very specific, like a big fork goes with the big forks. Then we have the small forks, and they have their spot. Big spoons go with big spoons. See here we have two big spoons. They're going to go right there. And little spoons with little spoons, and steak knives have their own spot over here. So combining like terms is very similar. You only put the same things together. In an algebra problem, it's going to look something like this, where you have 6x plus 2 minus 2x minus 5. Now I have my circles and squares up here. This is 6x, then 2 minus 2x minus 5, and it's all equal to 5. And when you're combining like terms, you can only put the same things together. Variables with variables, numbers with numbers, and if you look at the circles and squares, you can only put the same shape together. The color doesn't matter, it's the shape that matters. So you can only put squares with squares and circles with circles. On paper, it would be helpful maybe to put a square around anything that's made out of squares and put a circle around anything made out of circles. So in the problem it would look something like that, and that way it's an easy way to see what's going to go together. Now, if opposite colors come together, we say they cancel out, so they can actually just be taken away from the problem, and same thing with the circles over here. And then you can clearly see that if we put 6x together with minus 2x, we're left with 4x. And if we put a positive 2 together with a minus 5, we're left with minus 3. Now we're not going to combine with that stuff over there because that's on the other side of the equal sign, so that's all equal to 5. After I combine my like terms, I just solve the equation. We solve equations by doing opposites. We do the opposite of any addition or subtraction first. So since there's a minus 3, the opposite of that would be adding 3. And we show our work to both sides to keep the equation equal. Now on the left-hand side here, 4x minus 3 plus 3, these cancel out. The 4x would come down here. Sometimes I'll draw an arrow showing that it comes down. That's going to be equal to 5 plus 3. Well, 5 plus 3 is 8. Now I need to figure out what times 4 gives me 8. And to do that, I'm going to use division. Or if we're going along with opposites, the opposite of multiplying by 4 is dividing by 4. Now over here, 4 times x divided by 4 equals x. So I'm going to write that down here. And 8 divided by 4 is something that I can do either with long division or just knowing that 8 divided by 4 is 2. Now that I have a variable equal to a number, I'm done solving the equation. I can replace x with 2 up here, and I bet you that if we did all that work, this whole thing right here would equal 5. And that's kind of neat. That's combining like terms to solve an equation.